Hi, this is Matt Jacobs, Chief Strategy Officer with Penguin Computing. Thanks for joining me. I wanted to talk to you today about a compute collaboration between AMD and Penguin Computing to field research compute capabilities for COVID-19 research during the pandemic. At the onset of the pandemic, researchers were in need of additional compute resources to do the work that they had ahead of them to combat the virus. Computationally intensive disciplines like transmission modeling, protein dynamics, genomics, and vaccine development were calling for more and more resources, and they were not available in the market. Fortunately, AMD, under Lisa Su and her management team, stepped forward to donate compute resources to these researchers. In doing so, they needed to have a partner to engage with for the design, deployment, and management of these platforms, and Penguin Computing was fortunate enough to be contacted for this effort. So together, our teams came up with a creative model that would deploy some of these donated research capabilities on premises at customer facilities, and then some of them in the cloud through Penguin Computing's Penguin On-Demand HPC resource. And together, they created a very powerful deployment capability. In all, there were a multitude of grant recipients who applied to receive these grants. In total, 24 were selected across the United States and the globe. You see some of these here. These are organizations who had the greatest capability to move the ball forward on COVID research and to help us combat the disease, who already, in many cases, had very good programs in place that were in related or adjacent topics that could help. And so the first type of deployment we had was our on-premises deployments with our Penguin Computing True HPC solution. These on-premises deployments were often driven by customers who needed larger individual deployments. Some of them already had available data center infrastructure and space available that could accept these deployments. Some of them had really large data sets, especially in the AI arena, where they required more compute capability to be closer to the data sets, harder to move them around. And then, of course, there were others who just had unique security requirements and some data sovereignty requirements that would prevent them from leveraging a cloud model. Here, we had very robust platforms available to these grant recipients, Penguin Altus platforms that incorporated AMD's third generation EPYC processors, as well as their AMD Radeon Instinct MI50 GPUs, high-speed networks, and local storage. We deployed each of these with our skilled clusterware cluster management platform so that researchers could get up and running faster post-deployment. And then, of course, as I mentioned, a lot of design services, installation services, and managed services went into each of these unique deployments in the field. And the deployment sizes ranged from one server and smaller instances to larger 1 petaflop platforms. And you can see some of the work on the deployed platforms and happy recipients over there to the side. We also deployed a number of these HPC capabilities into Penguin Computing's pod, Penguin Computing On Demand. Fortunately, we already operate an HPC on demand platform. We had data center space available. We already had staff, of course, and then logistical methodologies in the software stack needed to convert these granted platforms into an HPC service for the research community that it was targeting. The cloud deployment model gave, of course, global access. Made us, give us the ability to immediately provision to the grant recipients who received under the cloud donation structure. There's an expert HPC staff on hand. This became critical as some of these newer users were absorbing some of these emerging technologies and learning how to get the most out of them. We have a lot of pre-configured applications on this platform and a full suite of remote visualization tools, which obviously became very useful while we were quarantined during the pandemic. Ultimately results in improved performance with high performance storage and networking. Our cloud platform under the COVID HPC fund at AMD got to the size of about 4 petaflops of total compute GPU resources. And you can see some examples of the access models below. The end result of the collaboration has resulted, as I mentioned before, in 24 grants, 4,000 researchers serviced under those grants on these research compute platforms. And by our estimates, over 12 million people positively impacted by the deployment of these platforms. There are a variety of published studies that have been conducted on these research capabilities, and a series of tech talks also available to look at. We're just getting started here. Unfortunately, we're still in the middle of a pandemic, and there's a lot of work yet to be done. And this probably won't be the last. And so preparing ourselves with the infrastructure and the research capabilities that we need to combat these problems in the future will be critical to faster response times. I hope you found the talk useful. If you'd like to learn more, certainly click on the link below and visit us at Supercomputing 21, either virtually or in person. And there's much more information available about AMD's HPC fund at the final link below. Thank you for your time, and I hope you have a great show.